Okay, so the region R in polar coordinates is all values r theta. The theta runs between 0 and pi. Yep, did it again. The theta runs between 0 and pi, and the r goes from the pole out to the curve. So the pole is r equals 0 out to 4 cosine theta. So our volume integral was a double integral over r of 4x minus the quantity x squared plus y squared dA. We're going to convert everything over to polar coordinates. So the limits on the integral, theta is going from 0 to pi, r is going from 0 to 4 cosine theta. The 4x is going to be 4r cosine theta minus x squared plus y squared is r squared. And the dA, remember, is r dr d theta. So this is the integral from 0 to pi, integral from 0 to 4 cosine theta. Multiply the r through here. We're going to get 4 r squared cosine theta minus r cubed dr d theta. So this is the double integral we're going to evaluate to find our volume. Okay, so we're going to evaluate the integral from the inside out. Integrate this with respect to r. 4/3 r cubed cosine theta minus 1/4 r to the 4th. And this is being evaluated from r equals 0 to r equals 4 cosine theta. And then this is an integral then with respect to theta. So this is the integral from 0 to pi. When I plug in the r equals 0, that's going to cancel out. When I plug in the 4 cosine theta, I get 4 cubed 64 times 4 is 256 thirds. I'm going to get a cosine cubed here and another cosine. That's cosine to the 4th theta minus 4 cubed 4 to the 4th, 256 divided by 4, 64. Cosine to the 4th theta here. D theta. We'll clean this up a little bit. 0 to pi. So 256 thirds. If I get a common denominator, I take 3 times 64. 3 times 64 is going to be 180. And 12 is 192. So I would need 256 minus 192. That's 4. 64. So 64 thirds. Cosine to the 4th. Theta d theta. So the 64 thirds I'll bring out front. That's a constant. And how do we integrate this? We could be fancy and use something like Wallace's formula, if you bother to remember that. Or else we can just break this down. That's cosine squared times cosine squared. And then use power reduction on each of these animals. So cosine squared, I'm going to have a factor of a half that comes out here, a factor of a half that comes out there. That's going to knock this down to 16 thirds, integral 0 to pi, and it's 1 plus cosine 2 theta. And I get that. D theta. So this is, just so you remember what we're doing here, these are our power reduction formulas. Cosine squared theta is 1/2, 1 plus cosine 2 theta. Now I got to multiply this out. Excuse me, I get 16 thirds, integral 0 to pi. What am I going to get out of this? I'm going to get 1 plus 2 cosine 2 theta plus cosine squared 2 theta d theta. Alright, so here's that integral. Now we'll break it up. I got 16 thirds, integral 0 to pi 1 d theta plus 32 thirds, integral 0 to pi cosine 2 theta d theta plus 16 thirds, integral 0 to pi cosine squared 2 theta d theta. Now the first integral we can do with amazing speed and accuracy. That's 16 pi over 3. The second one we can actually do with amazing speed and accuracy too. Because cosine 2 theta has a period of pi, I'm integrating a cosine function over an entire period. That's just going to zero out. So all that's left to reckon with is this animal. And we've got an even power of cosine. Use power reduction formula once again. The half comes out, gives you 8 thirds. Integral 0 to pi. What's left inside is 1 plus cosine 2 theta. Excuse me. Double the integral. 1 plus cosine 4 theta. So I get 16 pi over 3 plus 8 thirds. Integral 0 to pi 1 d theta plus 8 thirds. Integral 0 to pi cosine 4 theta d theta. And once again, the period of this guy is pi over 4. Excuse me, the period of this guy is pi over 2. I'm integrating over 2 periods, a cosine function over 2 of its periods. That integral is going to cancel out. So I get 16 pi's over 3 plus 8 pi's over 3 for a grand total of 24 pi over 3. Which I suppose I could reduce that then to 8 pi. So that'll do it for quiz 14.